for our exercise 3, notice that we have something a little bit different. We have an e and a power of negative x. The first step that we have to take is to leave the term with e to the power of negative x by itself. Okay? So let's work on that first. So we're going to leave this term of e negative x by itself. Okay? So the first thing that we have to do is that we have to move this 4 to the other side. Okay? So that's the first step that we have to do. So notice this 4 is automatically positive. So to move it to the other side, we do the opposite, which is negative, or subtract, right? So this cancels, so we are left with 5 e negative x equals 9 minus 4, that give us 5. Let's first get rid of this 5 that is multiplying the term of e with negative x as an exponent, okay? So 5 is multiplying, so if we divide by both sides, we're gonna get rid of this 5 here and this 5 here. Or we could say 5 divided by 5 equals 1, and then we just left with e negative x. So the left side, we are left with e to the power of negative x equals 5 divided by 5, that give us 1. Now, notice here, we have something to the exponent equals 1, equals some number, right? They are different bases, okay? They are not factors of each other, like in the previous examples, right? The 9 and 27 were factors of each other, and 2 and 8 were factors of each other. In this case, they are not. Now, here's the hint. Okay, we are dealing with the letter E, which is a mathematical number, okay? So, every time that you are dealing with E, we're gonna use the natural logarithm or natural log, ln, okay? Because there is one powerful property that involves ln and E at the same time, which is the following. Ln E of some number x, we are just left with x. That means that ln and E somehow cancels, and we are just left with whatever the exponent of E is. In this case, if it's x, we are just left with x, okay? So we are going to use that principle. That means that we have to apply ln into the both sides, okay? So we're going to introduce the ln, which is the natural logarithm, into both sides. So we're going to have ln of E of the exponent, in this case minus x, equals ln of 1, okay? Now, so notice from the properties of the natural logarithm involving E. In this case, the ln and the E somehow cancel, so we are just left with whatever the exponent of E is. In this case, is negative x. Now, we have natural logarithm of 1. Remember, log, let's do some notes. Log of 1 is equal to 0. And also, ln of 1 is equal to 0 by definition. Okay? So we have ln of 1 automatically is 0. Okay? So we have minus x equal to 0. So we need to somehow get rid of this negative. So one quick way is to multiply everything by negative 1. The whole equation by negative 1. Because notice, negative 1 multiplied by negative x, that leaves us with positive x, equal 0 times anything, in this case negative 1, equals 0. And that's going to be our solution for this problem.